for this equation, y is inversely proportional to x squared. So you can write y equals to k over x squared. And they say that given that x is always positive, find the percentage change in x when y is doubled. So in this case, y is doubled. Y is the one that changes, and you're supposed to find the corresponding change in x, okay, which is different in previous questions where they double x and then you find the change in y. So what you have to do in this case is first you make x the subject, okay? So you multiply both sides by x squared to get rid of the x squared in the denominator. So you have x squared times y equals to k. And then to get rid of the y, you divide y on both sides. Okay, so you have x squared equals to k over y. To get rid of the square root, you want to square root both sides. So you have x equals to k over y, x equals to square root of k over y, the positive square root, or negative square root of k over y. Remember when you square root, it's plus minus. Because like for example, if x squared equals to 4, then x can be 2 or minus 2. Because both, when you square both values, you'll get 4. So you need to consider both possibilities. Alright. But in this question, they state that x is always positive. Okay, so you reject the negative value. You still have to write it there, but you have to write the reject in brackets. Okay, so we know that this is how x is related to y. Okay, so when y is doubled, right, we're going to use another variable to represent that relationship. So we're going to let z be related to 2y, right, in this case. And then we try to compare how z is in relation to x. Okay, so we know that x is the square root of k over y. So we want to try to isolate that in z. So you can factorize out half within the square root. And then this is actually equal to square root of half times the square root of k over y. Okay, so we have isolated the square root of k over y, which we know is equal to x, right? So we can just write square root of half x here. So to find the percentage change, remember it's the new value minus the old value over the old value times 100%. Same thing, like same analogy that I gave in the previous example. If you scored 60 marks in term 1 and then 80 marks in term 2, your change in marks will be calculated by new value minus old value over 60 times 100%. Same idea here. So your new value is square root half x. Your old value is just x over your old value, which is x times 100%. So you factorize out the x, you get square root half minus 1 over x times 100%. The x cancels out, right? So you just square root half minus 1 times 100%. And this will be equal to negative 29.3%. Again, they're asking for percentage change, so you need a negative sign there. If they're asking for percentage decrease, you leave out the negative sign. So to try to make this question a little more intuitive to understand, we can try to use an analogy to see what's going on. Okay, so y is inversely proportional to x squared. We can think of y as a group of people. Okay, and we can think of x as the amount of food left in a crate. Food left in a red crate. Okay, let's paint it red. Alright, so you can see from this equation, the amount of food left is inversely proportional to or rather, this is how the amount of food left in the red crate is related to the group of people, the size of the group of people. Okay, so now we get a blue crate. We let z be a blue crate. Okay, x is the red crate. So for the blue crate, we let two groups of people rate the blue crate. Okay, like go and eat lah, right? And then we see what the blue crate weighs in the end, right? And then we compare it to the red crate. Okay, you can see that the blue crate. Oh, I forgot to write this equation. Right, always have this written out. After you get this step, right? You can see that the blue crate is a fraction of the red crate, which makes sense, right? A larger group of people will eat more food. Okay, so the amount of food left in the blue crate will be less than the amount of food left in the red crate.